All right, y'all, so this is the first lesson from chapter 3. So this is solving advanced linear formulas. So what we're going to say with all of this is when we solve for our variable, we want to solve for x. So what this means is that we're going to isolate the x term. And to isolate it, we want it all by itself. So sometimes we're going to have x's on both sides of the equation like we do here, sometimes only on one side. But what we're going to do is, like it says right here, we're going to get x alone, all by itself. So we have a problem like this, and this is simple. You've been doing this for years now. And so to get x by itself, we're going to subtract 10 from both sides. And this would give us 3x equals -2. Opposite here is we're going to divide both sides by 3. And we end up with x equals -2/3. Okay, so this one is fairly simple because there's not much that we have to do. But here it starts to get a little more challenging because we have x's on both sides. So when we want to isolate x, we want to get it all by itself. We're going to move our smaller value to the other side. So if you had me in pre-algebra, we said bring the baby to the mama. First thing that I want to do is combine like terms. So if I combine like terms, there are no like terms on this side and no like terms on this side, so I'm going to subtract 7x from both sides. And the reason why we move the smaller variable is so that this guy stays positive. So I have 3x plus 12 equals -3. So if I keep going, I need x by itself, so I subtract 12 from both sides, and this gives me 3x equals -15. When I divide, I have x equals -5. Okay, so now we're going to add in another step. So this was one variable on one side. Here I have variables on both sides. Here I'm going to add distribution on here. So I have to distribute this 10 into both of these. Okay, and so when that happens, I end up with 10x plus 20 equals 17x minus 3. So we said we're going to bring our smallest term to the larger term. So I subtract 10x from both sides. So this gives me 20 equals 7x minus 3. All right. So it doesn't matter that my x is on this side. I'm going to solve it the same way. So I add 3 to both sides now. And this gives me 23 equals 7x. So now when I divide both sides by 7, I get x equals 23 over 7. Now, we're going to leave this as improper. We're not going to put this into a calculator. We're going to leave this as improper, and we're going to leave it as a fraction. Okay? All right, so one more, but this one is a little more challenging. So here's what happens. I do not do this operation first. So order of operations says I have to multiply before I subtract. I don't subtract these two. So what I'm doing is I'm taking this -3 and I'm distributing this to both terms on this side of the equation. So this gives me 10 minus 6x plus 12. Again, I do not subtract first. This is a huge mistake that people make. I'm going to distribute the -3, and this is what it looks like. Now on this side, I have a negative that's right here. And so I'm distributing this negative into the parentheses. So on my other side of my equation, I have 5x minus 3x minus 7. This negative has to go to the 7 as well. So now I've got a lot of stuff going on both sides of the equation. So I'm going to go back and I'm going to combine like terms. So when I do that, over here I have -6x plus 22. So these I'm going to add. On this side of the equation, I have 5x minus 3x. So this gives me 2x minus 7. Now, one of the big mistakes that people do is on the same side of the equation, they'll say minus 12, and that gives them a -2. No, that's not what we're doing. If it's on the same side as the equal sign, we're going to combine like terms. Now we can subtract. So -6 is my smaller number, so I'm going to add 6 to both sides. And this gives me 22 equals 8x minus 7. So then I add 7 to both sides, and this gives me 8x equals 29. So x equals 29 over 8. All right, so big takeaway. Number 4 is a huge problem here. We want to make sure when we're distributing, we don't subtract first. Okay, so now we have a couple of fractions. And so if I look at these fractions, I could find a common denominator, and I could find a common denominator. I could add these, and then I still have this amount over here that doesn't have a denominator. But what I'm going to do, since I have 5 and 3, is I'm going to multiply this whole thing by 15, and I'm going to multiply this guy by 15. And when I do that, I get rid of my denominators. So if this is a denominator of 15, and I multiply this by 15, then what happens is I get rid of all of my denominators. So if I'm distributing, I have 5 into 15. So this becomes a 3 times 3x. And then I have 3 and a 15. So this becomes 5 times 2x. So let's do this again. 15 divided by 5 is 3. 15 divided by 3 is 5. And then on this side, I end up with 15x plus 30. So if I combine like terms over here, I'm going to have 9x plus 10x. So 19x equals 15x plus 30. Now, when I did this, all of my denominator goes away. Whatever I do to the left side, I have to do to the right side. That's why I multiplied this side by 15, even though there's not a denominator. So I subtract 15, and this gives me 4x equals 30. So when I divide this out, I get x equals 30 over 4. Now, in my other fractions, I've just left these at fractions, but this fraction simplifies. I can divide the top and the bottom by 2. So this gives me 15 over 2, and this is the answer that I want. Okay? All right, so now I'm going to look at this guy, and I want to see, well, what is my common denominator here that I'm going to use? And what I'm going to use on this one is 14. So if I multiply this by 14, and I multiply this by 14, then my denominator here goes away, and my denominator here goes away. And even though this doesn't have a denominator, over here we said you don't have to have a denominator. So what this looks like is 14 divided by 7 is 2. So I have 2 times 2x plus 5 times 14 equals 3. And the reason this equals 3 is because these cancel out. So what this gives me is 4x. And 5 times 14 is 70 equals 3. So now what I want to do is I want to subtract this out. So I have 4x equals negative 67. All right, so last step here. This is 4x, so I'm going to divide both sides by 4, and I'm going to have x is negative 67 over 4. And honestly, this might simplify, I don't know, but it doesn't reduce easily, so I'm just going to leave it like that for now. Okay? All right, here's what I'm going to do. I'm going to pause the video, and I want you to work these last two. No, hold on, never mind. I'm going to work this one, because this one's a little bit different. So I could multiply this by 15. I have a 3 here and a 5 here, and I can multiply this by 15. But because these equal each other, what I'm going to do is I'm going to cross multiply both of these. So if I cross multiply this, I have 3x minus 4. So 3 times this. Now I have to put this whole thing in parentheses because it's 3 times everything over there. And then on the other side, I have 10x. So I have 3x minus 12 is 10x. So I move the 3 over, and I have negative 12 equals 7x. So x is negative 12 divided by 7. Now, if you were to multiply both sides by 15, you're going to end up with exactly the same answer. Okay? So this one's a little more complicated. I'll give you a hint. These numbers are all multiples of 12. So go ahead and pause it and work this one, and then come back and check your answer. I ended up with 27 over 28. So go ahead and pause the video and look at that if you got a different answer. Okay? All right, let's flip it over. And now, looking forward here, what I have are a bunch of radical terms. So remember, radical is the same as the square root sign. So the radical means the square root. And so what we're going to do here is something super similar to what we just did. So first thing we're going to do is isolate the radical. And this means that it has to be all by itself. So I can have something underneath, so x plus 2 underneath. But what it means is it's just the radical on one side, okay? Then we're going to square both sides. And after we square both sides, we're going to solve for x. And then we're going to check for something called extraneous solutions. And I'll talk about that when we get through here so you can see this. All right, so this one is already isolated. Remember, step 1 is isolate the radical. So this is already isolated. All I have is a radical on one side. So I'm going to square this side, and I'm going to square this side. And when I square a radical, the radical is really to the 1/2 power. So I have x to the 1/4, x minus 4 to the 1/2 power. That's what this radical means. And when I square it, this cancels out and the whole thing goes away. So the reason we want the radical all by itself is because when we square it, it goes away. And I have x minus 4. And then on the right-hand side, 9 squared is 81. So when I subtract, I'm going to add 4 to both sides. I get x equals 85. And that's my final answer. Now, I can plug it back in and check it. So what this would be is 85 minus 4. So if I take 85 and I plug it back in, 85 minus 4, so the square root of 81 equals 9. And that's what we started with. All right? So with number 10, this is not isolated because I have this plus 1 hanging off the end here. So I'm going to get that, I'm going to move that plus 1. So I subtract it from both sides and I end up with 3x minus 8 equals 2. Now, again, this is isolated. Doesn't matter that I have other things going on here. So I'm going to square this side and square this side, and I have 3x minus 8 equals 4. When I square 2, I have 4. So 3x equals 12, and x equals 4. Now, I could go back in, and I could test that and see what I end up with, but I'm pretty confident in that answer. So let's keep going. All right. So over here, my radical is just square root of x. So I have to move everything. So just like before, we're using opposite operations. So I'm going to subtract 8 first. So this gives me 1/2 square root of x equals negative 3. Okay? And now what I'm going to do is get rid of this 2. So if I get rid of this 2, to get rid of the fraction, I have to multiply by the reciprocal. So I multiply this side by 2. And I multiply this side by 2. And what I end up with here is the square root of x equals negative 6. Okay, so at this point, I am going to mark this as extraneous. So here's why. I cannot take the square root of any number and get a negative 6. What I can do is take the square root of a number and get 6, but not negative 6. So this is extraneous solution, so there's no real answer. Now, here is the problem with this, and this is why you have to think about this. Whenever it's isolated, up here this is positive, up here this is positive, but here it's negative. So when your radical is isolated, you have to make sure that this is not a negative number because I can't take the square root. Here's the problem. If I took square root of x equals negative 6 and I square this side and I square this side, I get x equals 36. And that looks like it can be a real answer. And so if I took that value and I plugged it back in, this is what I would have. Let me work it up here. So I would have 1/2 times the square root of 36 plus 8 equals 5. Okay? Now, up here, I proved to you how that's true, how it works. So the square root of 36 is 6. So I would have 1/2 times 6 plus 8 equals 5. Well, 1/2 of 6 is 3. 3 plus 8 equals 5. And this is not true. 11 does not equal 5. So what happens is when you have a negative number, you have to, and this is isolated, your radical's isolated, it becomes an extraneous solution. Okay? All right. Let's look at number 12. So number 12 is pretty interesting because I have a radical on this side and I have a radical on this side. And so these are both isolated. So because they're both isolated, I'm going to square this side and I'm going to square this side. And we know that when we square a square root, it just becomes whatever value is underneath. So when I square both sides, then it becomes super easy. I get rid of my 2x. I have -1 equals 3x. Now, it's okay that this is negative now. It's okay because I don't have a radical anymore. So I'm going to divide both sides by 3, and I get x equals -1/3. Okay, let's see, last one here. So this one is a little harder because I can't isolate it any more than I already have. So I can't do anything with this 1/2. I can't do anything with this 3 because they're both still there. Sorry. So what I'm going to do just to make it easy is I'm going to get rid of this fraction. So I'm going to multiply both sides by 2. And this gives me the square root of x equals 6 times the square root of 2x minus 1. And this is as isolated as this gets because there's nothing else I can do with the 6. Everything else, like if you look at the problems up here, this could equal 6, but I can't do that here. So when I square both sides, I'm going to square this side, and I'm going to square this side. The left side's easy, it becomes x. But now I have to square what's on the outside, so I have 36. And then I lose my radical on the inside. So now this is what I have. So again, I squared this, it's just x. When I squared this, I squared the 6 and get 36. And then I lose my radical. So I have to distribute at this point. So I have x equals, hold on, what is that? 72 minus 36. 72x minus 36. Okay, so I subtract x from this side, but I'm going to add 36. So I get 71x equals 36. So x is going to be 36 over 71. I went through that really quickly, so make sure you pause this and go through it again so you understand where that came from. Okay? All right, last concept. Now this is historically something that people struggle with. So what we're doing here is we are solving for a variable. So it says solve for the indicated variable. So everything that we've had on this first part of this, we were just solving for x. Now, what makes this hard is we don't have a lot of numbers. So if we're solving for w, we're just using our reverse operations. So what this means when we're solving for a variable is you're going to move everything away and isolate the variable last. Okay, so if I'm looking for w, this is what's going to get isolated last. So I have to move the 2L. So if this is positive, I'm just going to subtract 2L from both sides. Well, I can't combine these. They're not like terms. So I have P minus 2L equals 2W. P minus 2L, I just subtracted it. This went away. 2W on this side. I'm solving for W, so I'm dividing both sides by 2. So W equals P minus 2L over 2. And this is my final answer. Now, one thing that people do, and it's wrong, but a lot of times people will be like, oh, 2 cancels with 2. And you can't cancel that because really what you have here are two fractions with a common denominator. So this is the same as P over 2 minus 2L over 2. Well, if I write it this way, then those 2's cancel, but I have to make sure that the P still stays over the 2. So if you're going to write this as two different fractions, then this is what it would look like. So either the whole thing's over 2 or you have to write it this way. Okay? All right. Next one, we're going to solve for r. So I want to isolate r. Well, there's nothing else to move until I get over here. And so the operation that happens between the between the pi and the r squared is multiplication. So I'm going to divide by pi. And this gives me a over pi equals r squared. Now, we just talked about how we solve something that's squared. The opposite of squaring something is the square root. So I'm going to take the square root of this side, and I'm going to take the square root of this side, and I end up with r equals the square root of a over pi. And this is my final answer. Okay? I am going to have you do 16 and 17 on your own, and then pop back and we'll check your answers. Okay, here are two answers. If you wanted to, you could get rid of this negative in the denominator. You could also put the 3x first. So another answer that's correct would be something that looks like this. If you put the 3x before the 8, which is normally what we do when we're putting this in slope-intercept form. The other thing you can do is you could multiply the negative 5 all the way out, and you would have 3x minus 8 over 5. So these are also acceptable answers. Now this one's tricky. So I could have distributed everything through and then started moving and dividing, but what I did is I divided by 5 first, and then I added 2 on the end. So what you see is that this part, this plus 2, is not over this common denominator, right? Y minus 3 has a common denominator, but this plus 2 is on its own. Okay? All right, so let's solve this volume equation. So this volume equation is a little tricky because we're looking for h. So again, we're going to move everything that is not connected to the h, which means I'm moving this br. So I have v minus br equals 1/2 bh. I don't want to get rid of the 1/2 first. I have to move everything that's not connected to h. So now what I'm going to do is get rid of this 1/2. So to get rid of a fraction, I multiply by the reciprocal. So I have to multiply this whole thing by 2. So I'm just going to leave this. I could distribute it if I want to, but I'm not going to. So I have 2 times all of this. I got rid of this 1/2. Now, if I'm solving for h, I'm going to divide that by b and divide this by b. So my final answer here is 2v minus br over b. And again, these b's can't cancel because I don't have any b's over here. All right, last one, solve for b. So I have b here and I have b here. So this one's tricky. So what you have to do when you have this is you have to isolate the b term, which means if this has b and this is b, I can factor this out. So I have a b. What's left on the inside is a plus c. Now, if you want to see this, make sure I'm right, it's b times a, which is ab, and b times c, which is bc. Now, this is multiplied together. So b is multiplied by all of this. That's what happens when we factor, is we create this multiplication. So all I'm going to do is divide the whole thing by a plus c. So I divide this side by a plus c. Now, when I factored this out, I had to have parentheses because the parentheses tell you that it distributes, but I don't have to have parentheses here when I divide. If you want it to look exactly the same, you could put parentheses there if you want to. But because there's nothing else happening in the denominator, I'm going to leave it like that. All right, I went through this super quick, so make sure you go back through and pause or work some of these problems and come see me.